Welcome to the Kentucky Labor Cabinet Office of Occupational Safety and Health online training resource. This class is presented as a service of the Division of Education and Training. Please read the following disclaimer, and when you're ready to continue, click the forward arrow below. Welcome to the course, Slings in General Industry. This presentation will cover the standards for slings in general industry, which can be found in 29 CFR 1910.184. First, let's go over some definitions of terms found in the 1910.184 standard that will be used during this course. The angle of loading is the inclination of a leg or branch of a sling measured from the horizontal or vertical plane. A hitch is a sling configuration whereby the sling is fastened to an object or load either directly to it or around it. The rated capacity or working load limit is the maximum working load permitted by the provisions of this section. And lastly, shock loading is the sudden increase in weight on a sling. 1910.184C covers general operating practices that need to be followed whenever any sling is in use. Never use a sling that does not have an affixed and legible identification tag, as this contains information you will need to know about how to use the sling properly. A damaged or defective sling cannot be used and must be removed from service. Never shorten a sling with knots, bolts, or any other makeshift devices. Do not load slings above their rated capacities and do not shock load a sling. Whenever a load is resting on a sling, do not pull the sling out from under that load. Always securely attach loads and balance loads to prevent slippage. Clear all obstructions and persons from the path the load is traveling. Always consult the manufacturer before using a sling in a chemically active or high-temperature environment. And lastly, whenever you are using a sling, remember that it is only as strong as its weakest component. These are the types of hitches used when lifting loads. Different hitch types are used based on the sling, the load shape, size, and weight. Also, the weight capacities vary depending on the type of hitch used. During this course, we will review rated load capacities for each sling. However, there are many factors that determine those capacities. This presentation will review the characteristics of the slings that determine rated capacities, but it is important to note that rigging practices also play a huge role in determining those capacities. The rated loads are also dependent on the type of hitch and the angle of loading for the hitch, specifically basket and bridle hitches. When the angle is lower to the horizon, there is more tension on each leg, thus decreasing the rated load capacity. To put this concept into perspective, imagine carrying two buckets, one in each hand. When you lift your arms away from your body, you will notice the tension in your arms, and it becomes more difficult to hold the loads. And it is always important to consult a manufacturer and/or a designated qualified person before selecting and using a sling to do a vertical lift. Some inspection requirements that are applicable to all types of slings include: slings must be inspected each day before use, and periodic inspections should be at least yearly. The periodic inspections can be determined based on how frequent the sling is used, how severe the conditions are on the sling, the nature of the lifts being made, and based on experience. If you have noticed a trend in service life in slings in your facility, you can base the periodic inspections on that experience. A general rule of thumb is yearly inspection for slings that are in normal use, quarterly for slings in frequent use, and monthly for slings that are in severe use. It is also important to note that although OSHA standards do not require a written record of inspections for every type of sling, the American Society of Mechanical Engineers standards does contain provisions on inspection records. Now let's take a look at the different types of slings. This presentation will cover alloy steel chain, wire rope, metal mesh, fiber rope, and synthetic web slings. Alloy steel chains are the first type covered in the standard. These are known for their high strength and durability, making them ideal for harsher environments. They are also easy to inspect and are repairable, but remember, any repairs must be recertified. Only slings that are repaired, reconditioned, and proof tested by the sling manufacturer or a qualified person can be brought back into service. The ID tag must include size, grade, rated load, number of legs, the sling ID, and the name of the manufacturer. The most common grades are 80 and 100. Alloy steel chains widely vary in configuration, and you'll see this configuration in an acronym. The first letter will identify the number of legs as single, double, triple, or quad. The second and third letter will identify the first collective ring, and second, the end attachment. The letter will be O for oblong ring, S for sling hook, G for grab hook, F for foundry hook, and J for a J hook. You can also add shorteners, a chain that is not uniform to the leg. You will see A for a 2-inch shortener and B for a 1-foot shortener. The rated load is dependent on the grade, chain size, number of legs, hitch type, and horizontal angle. The table provided by OSHA for grade 80 alloy steel chain slings, vertical and bridle hitches. OSHA also provides tables for grade 100 vertical and bridle hitches, and grade 80 and 100 for choker hitches. For other materials and configurations that are not provided, use rated loads according to the sling manufacturer or qualified person. Some considerations while inspecting this type of sling are evidence of wear, defective welds, nicks, cracks, breaks, gouges, bends, and discoloration due to excessive heat. Also look for excessive pitting or corrosion. The chain links will stretch when overloaded and with long-term use. Always ensure the sling ID card is attached and legible. This type of sling is the only type that has a requirement to maintain an inspection record. 1910.184E3 Roman numeral 2 requires that the employer make and maintain a record of the most recent month in which each alloy steel chain sling was thoroughly inspected. This record must also be made available for examination. The biggest advantage of this type of sling is its ability to withstand harsh environments. It is capable of withstanding impacts in working environments where there is UV exposure and exposure to dirt, oil, and grease. Being able to withstand 1,000 degrees Fahrenheit makes this sling able to withstand the highest temperatures when compared to other types of slings. However, whenever working in temperatures above 600 degrees, rated load should be reduced in accordance to the manufacturer's recommendations. The next sling covered in the standard 1910.184F is wire rope. These are lower in cost and quite versatile in that they come in several configurations to match the needs of the job site. The identification tags should include the rated load for types of hitches and the angle at which it is based, diameter or size, and the name or trademark of the manufacturer. Classifications are based on the number of strands as well as by the number of wires in each strand. The two categories are 6 by 19 and 6 by 37. However, these are nominal classifications and may or may not reflect the actual construction. The 6 by 19 class will include 6 strands with 16 through 26 wires, and the 6 by 37 will include 6 strands with 27 through 49 wires. Many configurations of the material, wire, and strand structure will provide different benefits for the specific lifting application, but also come with some trade-offs. If you have a wire rope that has fewer wires, it will have a larger diameter wire, which provides better abrasion resistance, but with reduced flexibility. If you have a wire rope that has more wires, it will have a smaller diameter, which provides better flexibility, but reduced abrasion resistance. This is a cross-section of a 6 by 19 wire rope, and you can see that it has a core with 6 strands consisting of 19 wires. The rated loads for this type of sling are dependent on the material, design factor, the type of hitch being used, and the angle of loading. The link provided will open in a new window, and there you will find charts for several configurations. For any configurations outside these charts, consult the sling manufacturer or your qualified person. Some considerations for inspecting this type of sling include looking for broken wires. If there are 5 broken wires in one lay or 10 in the total length, then the sling must be removed from service. Also look for severe abrasions, scraping, kinking, crushing, and bird caging. This is an example of bird caging. Look for any heat damage on the rope or the attachments. Also examine the attachments for deformities or excessive wear. Wire rope slings can be very difficult to inspect due to their design, and they are non-repairable. When considering the use of this type of sling, you must consider the environmental factors. These slings should not be used in temperatures exceeding 400 degrees or below minus 60 degrees Fahrenheit. They can be susceptible to both internal and external corrosion. Also, depending on the configuration, they can have low fatigue resistance, so be mindful of the configuration before using in a harsh environment. 1910.184G covers metal mesh slings. These are generally made up of steel material which is woven together, and they are mostly used in environments where the loads are hot and abrasive. The identification tag must include rated capacities for the vertical, basket, and choker hitch, the angle, the width, gauge, and the name or trademark of the manufacturer. Rated loads are dependent on the gauge and width of the sling. The smaller the gauge, the stronger the sling, the wider the sling, and the more weight it can hold. Rated loads are also dependent on the type of hitch, the angle, design factor, and the material strength. Things to look for during inspection include broken wires, broken welds, or broken braze joints. Also look for the reduction in wire diameter, lack of flexibility, distortion, cracks, and lock spirals. Examine the fittings for pitting, corrosion, cracking, bending, twisting, and gouging. Any of these conditions will require the slings to be removed from service, and this type of sling is only repairable by the manufacturer or equivalent entity. Metal mesh slings are strong, durable, and are capable of withstanding harsh working environments, but can be susceptible to crushing damage. They can be used in temperatures from -20 degrees to 550 degrees Fahrenheit, but if there's an elastomer coating on the sling, the range is reduced to 0 to 200 degrees Fahrenheit. 1910.184H covers fiber rope slings. These are generally made of nylon or polyester materials and are lightweight, flexible, and easy to rig. This type of sling is also soft and will protect loads from abrasions. The identification tag should be marked and legible with the following information: the rated load for the types of hitches, and the angle upon which they are based, the name or trademark of the manufacturer's code or stock number, and the type of material and construction of the sling. The most common constructions for fiber rope slings are 3-strand laid, 8-strand plated, and hollow braided nylon and polyester. The rated loads are based on the material strength, design factor, type of hitch, and angle of loading. Rated loads for single leg, choker, and basket hitches are provided. This table provided by OSHA is for nylon rope slings based on design factor. Any lifts outside this table should be consulted with the manufacturer or qualified person. This type of sling can be very difficult to inspect, as you will need to examine the inner strands as well as the outer strands. Considerations while inspecting this sling include cuts, gouges, and areas of extensive fiber breakage. Visible powdered fiber between the strands would be an indication of inner strand abrasions. Look for damage of 10% or more of the rope diameter, and look for fuzz, whiskers, fiber breakage, melted fibers, excessive dirt or grit, and check the interior for any foreign matter. The environmental considerations for fiber rope include the following. The temperature range is -40 to 194 degrees Fahrenheit. Some synthetic yarns do not retain their strength during long-term exposure above 140 degrees Fahrenheit. Also, long-term exposure to sunlight or ultraviolet radiation can affect the strength of natural, nylon, and polyester fibers. Be sure to consult the manufacturer on both of these conditions. Synthetic rope is not as durable as steel slings in that they will experience cutting, fraying, and abrasion if used to lift loads with edges. 1910.184I covers synthetic web slings. These are inexpensive slings that are made of nylon or polyester. They are strong, flexible, and gentle on loads. The identification markings required on this sling include the rated load for each type of hitch, sling material, manufacturer or stock number, and the trademark or name of the manufacturer. Synthetic web slings have 6 different types. Type 1 has a triangle fitting on one end and a slotted triangle choker fitting on the other. This type can be used on a vertical, basket, or choker hitch. A Type 2 sling is made with a triangle fitting on both ends. Type 2 slings can be used in a vertical or basket hitch only. Type 3 is a sling made with a flat loop eye on each end, with a loop eye opening on the same plane as the sling body. This type of sling is sometimes called a flat eye and eye, or double eye sling. Type 4 is a sling made with both loop eyes formed as in a Type 3, except that the loop eyes are turned to form a loop eye which is at a right angle to the plane of the sling body. This type of sling is commonly referred to as a twisted eye sling. Type 5 is called an endless sling, or sometimes referred to as a grommet. It is a continuous loop formed by joining the ends of the webbing together. And Type 6 is called a return eye or reversed eye sling, and is formed by using multiple widths of webbing held edge to edge. A wear pad is attached on one or both sides of the sling body, and on one or both sides of the loop eyes to form a loop eye at each end, which is at a right angle to the plane of the sling body. Rated loads for synthetic web slings are based on material strength, weave construction, type of hitch being used, and the angle of loading. OSHA provides a chart for rated loads, but please consult the manufacturer or qualified person for lifts outside the provided chart. The considerations while inspecting this type of sling are signs of acid or caustic burns, and any melting or charring of the sling. Look for holes, tears, cuts, broken or worn stitching, abrasions, or discoloration. Slings should not have any brittle or stiff areas. Also look for pitted, corroded, cracked, bent, twisted, or broken fittings, and slings with any of these conditions must be removed from service. Synthetic web slings made of polyester and nylon shall not be used at temperatures in excess of 180 degrees Fahrenheit, and polypropylene web slings shall not be used at a temperature in excess of 200 degrees Fahrenheit. Polyester is more resistant to acidic environments but susceptible to alkaline environments. Nylon slings can be affected by oil and grease, are resistant to alkaline-based chemicals, but are susceptible to acidic environments. The strength can also be affected by excessive UV light exposure. With all this considered, be sure to consult the manufacturer before using any of these slings in any chemically active, outdoor, or high-heat environments. This concludes our course, Slings in General Industry. Please check out our website for more online learning opportunities, and as always, thank you for taking this course.